Great. So yes, as I said, my name is Stefan, and I will talk about our application function. I'm one of the co-founders from phine.tech. Lucas is also my second co-founder, and we have written an application function to bridge CAMARA, quality on demand, APIs, and many more with the whole core network N5 connectivity and so on. Before I start, a little bit about us because we might not be that well known yet. So we are a startup based in Vienna. We founded 2023, so we're 3-year-old. And what is important here is that we do a lot of open source contributions. So we're really a key contributor, especially in the core network for open air interface. And this is also how we got to know 5G Mark. And a little bit about our backstory. Why are we here? So actually, we met with Jordi at MWC 2026. We very quickly realized there's a lot of synergies, and that also led us to join now 5G Mark beginning of May, which was very fast, and I'm very happy about that. We see our role here is that we actively want to contribute code, testing, documentation, everything which is necessary for all the reference tools. And we have a very big interest in the whole MBS topic. So our first step is to validate that, test that, and even maybe contribute some smaller fixes or issues. Midterm, we want to establish, joint projects going above that scope of MBS. And short term, it is about our application function, the phine.af, which I will talk about today. Yes, so let's start with the details about the application function. So we really see this application function as kind of a programmable 5G bridge. So we have developed that in C++. It is a little bit based on the OEI repository code because we're very familiar in that, but we have stripped it to really fit our needs here. So we exposed the 3GPP 5G capabilities on the one hand, and also on the other hand, third-party domains. But it's kind of an orchestration layer between translating this application into the telecom world policy and routing. And our vision here is to go more a dual path integration. So for all the northbound interfaces, we want to have a standardized access. Here we have developed CAMARA APIs for really the standardized telco API exposure. But we think it's also important that it should be easy to have some domain specific, let's call it proprietary customization. So it's very easy to just use the standardized models, but build your own API for your own use cases. And the current capabilities of the application function are quality on demand. So we have an end-to-end CAMARA API QD workflow. We tested that also end-to-end using a free 5GC core OAI UPF, and that works really well. Policy management, so we can translate what comes from the application into PCC rules for the PCF, event subscriptions, getting information, for example, about PDU session changes, and also UE state tracking based on different identifiers, especially IP and SUPI. And towards the core we have implemented so far is the N5 interface towards the PCF. Planned capabilities on our side are the device location API, also based on CAMARA. It's quite an interesting thing, especially if you have 5G localization, to expose the API in a little bit easier way than what the 5G APIs give the users. Traffic influence, we're also working on that. Probably we will be working on the N33 NEF interface. This is really if there is demand. Same goes for the binding support function. And we will also have a look towards the TSN topic, so especially integrating the support for the TSC, TSF here. And the whole architecture of the application function is basically built on 3 different layers. So we have the northbound layer, and this is really for us the protocol adapters. This is how applications interact with the AF and then also the whole 5G system behind it. So we just translate these external protocols. It can be HTTP, can be HTTP2, can be REST, can also be gRPC, or even domain specific, like we have built a robotics integration. I will talk about that later. And the idea is again to just easily extend these proprietary enterprise protocols alongside CAMARA APIs. Then we have the AF core, and this is really the business logic and the whole orchestration part. So we have an orchestrator, a request router, and it's just about message dispatching between the different parts. I will show an architecture later, so I think it's getting a bit more clear what we do here. And we have domain managers. So the point is really this whole quite honestly complex 3GPP procedures, logic, 5G core should be more or less abstracted by the AF. So for a user, for an application querying or interacting with the AF, it should be as easy as possible. So this whole UE state management is all in there. And then also we have an event dispatcher, for example. There's an internal pub sub mechanism. So for example, if we see a PDO session is terminated, we can do a quality on demand cleanup and all these kind of things. And the idea is again that the AF takes away most of the complexity of the state management. And on the southbound layer, that's the 3GPP, that's the 5G part. It translates these internal domain models into 3GPP compliant APIs like N5, N33, and so on, like everything which is there. As I've said before, N5 is currently implemented. And the architecture is done in a way that it's quite easy to adapt it to work with N33 or the BSF or even the TSC, TSF. And we have separated these layers. It's not one box. We have separated that to really enable a decoupling of the different components. Again, it's really about the ease of use from an application perspective. And also it's very easy extensible for other standardized or not APIs and protocols. This is how it looks like. I don't want to go into detail. Probably you can't even see that really well in the screen sharing. Just important to note, this is the 5G core network with all the components. This is the RAN and UE, and this is the application function. I just want to talk a little bit more about the application function. Basically, here we have the northbound adapters, QD CAMARA, device location CAMARA, TSN REST netconf maybe. And it could also be something very app specific. And basically all these communicate with the AF core. And the AF core then translates that into the requirements 3GPP has, for example, using the PCF handler to communicate with the PCF. And this is really about abstracting the different layers here. All these components, they need to communicate. So the communication between these different parts is done using gRPC. So this requires multiple binaries to run. You need an AF core binary, you need a northbound, you need a southbound, you need a PCF handler, etc. Of course, everything is containerized, so you can just run that as a Docker compose. It can become complex, it can introduce latencies. That's also why we have written a different deployment mode where everything is running together as one monolith. So you would see it as one application function that does everything for you. And basically the whole gRPC communication becomes directly in process. And it's quite easy to change that. It's just configuring that via YAML file and you're good to go. Just here again, a little bit to show how that works. So we have the northbound layer. You have the different APIs, different adapters. Then you have gRPC or internal communication depending on the configuration. You have the AF core with the whole business logic. And then you have the southbound layer, which then talks to the 5G core network. Yeah, and really this architecture is really that it's very easy to extend it and to add different new things in the development cycles. So if you want to write a new northbound adapter, you only need to generate these message protosubs from gRPC. And basically you just need to hook it up internally and you're good to go. And if you want to add new capabilities, let's say the device location API, you need to define the models internal for the shared library for the models. Then you need to create the service logic, of course, the business logic inside the AF core. And then you just need to register the handlers and you need to wire all these layers together. And it gives you a lot of features already. For example, with this pub sub, you get the events, so you can kind of write your business logic based on that. And finally, I just want to show you a little bit of an example that we did for our use case. So we have a use case where we're basically remote controlling a robot and in a private 5G network. And that is quite challenging for the private 5G network. We have a lot of video upstream, which could get into the limit quite quickly. And what we have done here is we have written a node we call 5G ROS gateway. And this 5G ROS gateway takes the quality of service on the application layer, on the robotics communication layer, and automatically translates that into 5G QoS. And we have done it exactly using our application function. So basically, this node here registers what the robots are sending. Is it a video stream? Is it a control message? Is it a control loop, etc.? And based kind of divides these streams and then sends it to the application function via the CAMARA QD API. Hey, for this stream, I need this certain level of quality of service. And then, of course, it's being provisioned in the core network and so on, but don't want to go into detail there. So basically, all we had to do here, we have the application function. All we had to do here is to write this ROS node that understands what is happening in the network. Great. Finally, so what is the current status in Outlook? The application function is not yet open source. It's still kind of under the level of internal development, but we have been in talks with 5G Mag and Hodi especially that we will open source it very soon on our GitHub. And for us, we would really be happy if this application function becomes the go-to application function for all the reference tools. And we will develop our own, a lot of different use cases around it, but we're also very happy to support 5G Mag and all the partners here with various different AF enabled use cases. Well, thanks everybody. That's so much from my side. So I'm not sure if we have time for any questions or not, but thank you.